Well, hello there. Sion Batson here from Sion Batson Tutoring. And in this video, I will be teaching you how to simplify fractions before multiplying fractions. A very important concept for 5th grade students, 6th grade students, 7th grade students, and GED students. So let us go. You might be asking, why do I need to simplify the fractions before I multiply the fractions? Well, simplifying the fractions allow us to make the numerators and the denominators as small as possible before multiplying. And hey, life is much easier when multiplying small numbers. Yes? How are you feeling? All right. Now, if you want to simplify fractions before multiplying the fractions, the rule says we can divide a numerator and a denominator that are diagonal to each other by their greatest common factor, or the GCF. It's a very simple rule. Yes? If you want to simplify fractions before multiplying the fractions, you will simply divide a numerator and a denominator that are diagonal to each other by their greatest common factor. That's it. Now, after simplifying the fractions, we will multiply the new numerators, then we will multiply the new denominators, and we will be done with the fractions. How are you feeling, my friends? Come on, man, let's get pumped. Let's go to our first example here. We have 5/8 times 4/15. So, before we multiply, we are going to simplify. Yes? And again, if we want to simplify the fractions before we multiply the fractions, we will divide a numerator and a denominator that are diagonal to each other by their greatest common factor. So let us simplify. We will start with the numerator here, which is 5, and the denominator here, which is 15. Again, this numerator and denominator are diagonal to each other. Yes? To simplify the 5 and the 15, we will divide the 5 and the 15 by their greatest common factor, or the biggest number that can go into 5 and 15 evenly. Now, can you tell me what is the greatest common factor for 5 and 15? Well, the greatest common factor for 5 and 15 is 5, because 5 is the biggest number that can go into 5 and 15 evenly. Yes? So to simplify the 5 and the 15, we will divide the 5 first by 5, and 5 divided by 5 is 1. So our numerator here, which is 5, is shrunk, and it became a 1. Yes? And we will divide the denominator as well, which is 15, by 5. And 15 divided by 5 is 3. So our 15 is also shrunk. Yes? And it's now a 3. Note, I divided the numerator and the denominator by the same number. I divided both by 5. When you're simplifying, you must divide the numerator and the denominator by the same number. whatever the greatest common factor is, you must divide both the numerator and the denominator that are diagonal to each other by that greatest common factor. Yes? All right. Now, let's look at the other pair of numerator and denominator that are diagonal to each other, the 4 and the 8. Again, to simplify this 4 and this 8, we can divide them by the greatest common factor. Yes? The greatest common factor for 4 and 8 will be the biggest number that can go into 4 and 8 evenly. Can you think of that number? Well, that number is 4. 4 is the biggest number that can go into 4 and 8 evenly. So we will divide the numerator 4 by 4. 4 divided by 4 is 1. So again, we will shrink our 4 to a 1. Yes? Or reduce the 4 to a 1. It's getting smaller. Yes? And we will divide the denominator, which is 8, by 4 as well. 8 divided by 4 is 2. Yes? So our 8, we have successfully shrunk the 8 to a 2. Yes? Again, note, I divided the numerator 4 and the denominator 8 by 4. I divided both of them by the same number. Yes? And that number is the greatest common factor for 4 and 8. Yes? All right. Now, let's see what we are left with after simplifying. After simplifying, our 5 shrunk down to a 1, and the 8 shrunk down to a 2. Our 4 shrunk down to a 1, and the 15 shrunk down to a 3. Ah, look at this. Take a minute to look at what's happening. We went from 5/8 to 1/2. We went from 4/15 to a third. Yes? That's the purpose of simplifying. We will get smaller numbers to multiply. Yes? Now, after simplifying, we will multiply the new numerators. 1 times 1 will give us 1. And then we will multiply the new denominators. 2 times 3 will give us 6. So our final answer is 1/6. How is that? I know you were saying, man, that looks like a lot of time. Don't worry with the timing. The purpose of simplifying is to multiply small numbers. Yes, that's the goal. That's the plan. To multiply numbers that are as small as possible. Yes? Now, just in case you need to review how to find the factors and the greatest common factors of numbers. Yes? I got you. I did a very detailed step-by-step video that will help you find the greatest common factor. Yes? Watch that video. Practice, master the skill, and then come back and join us if necessary. Yes? So our final answer here is 1/6. How are you feeling? Come on, man. Let's get pumped up in here. Let's get pumped. Now, I know somebody is there saying, well, why am I going to simplify when I can just multiply? Right? Now, let me show you the difference if you were to skip over the simplifying step. Let's say we're going to we have 5/8 times 4/15. And my smart friend right there is saying, I'm not going to simplify, Sion. I'm going to just go straight ahead and multiply. Let me show you why. You should always simplify before you multiply. If you want to go ahead and just multiply, when multiplying fractions, you will multiply the numerators first. So 5 times 4 will give us 20. And 8 times 15, you multiply the denominators next. 8 times 50 will give you 120. Look at that! Who wants to work with those big numbers? Do you want to work? Nobody wants to work with these big numbers. That is why you want to simplify before you multiply. Of course, if we were to simplify or write 20 over 120 in the simplest form, we will divide both the numerator and the denominator by 20, and we will still get 1 over 6, or 1/6, yes? But why work with this monster when you can work with these babies? Come on! How are you feeling? Simplify before you multiply. Come on! Ooh, I am pumped up today. I hope you guys can feel my energy. Now quickly, if you are new to my YouTube channel, welcome. And thank you for joining. Yes? Welcome to the math party. Now, kindly click on the subscribe button and turn your notifications on so that you can be notified every time I post a fun, exciting, and easy to follow math tutorial. Yes? Thank you. Now, let's keep the party going. All right. Whew. Don't forget, what is our song for the day? We are going to simplify before we multiply. Simplify before you multiply. Do you hear me, Jada? Do you hear me, Leah? Riley, do you hear me? Annalise, do you hear me? Tyler, do you hear me? Aaron, do you hear me? Savannah, do you hear me? Simplify before you multiply. Let's keep the party going. So we want to multiply 5 12s by 24 over 25. Woo! So again, before we multiply, we are going to simplify. And the rule says, if you want to simplify the fractions before you multiply the fractions, you can divide a numerator and a denominator that are diagonal to each other by their greatest common factor. So let's start with the 5, which is a numerator, and the 25, which is a denominator. And we can simplify these two because they are diagonal to each other. If we want to simplify 5 and 25, we can divide 5 and 25 by their greatest common factor. Again, the greatest common factor for 5 and 25 will be the biggest number that can go into 5 and 25 evenly. Yes? The greatest common factor for 5 and 25 is 5. 5 is the biggest number that can go into 5 and 25 evenly. So we will divide 5 by 5. 5 divided by 5. That will give us 1. So we have shrunk our 5 to a 1. And then we will divide 25 by 5. And 25 divided by 5 is 5. So we have shrunk 25 to a 5. It's looking good so far, yes? I love working with small numbers. Come on. Working with small numbers make math even more exciting. Yes? Now, let's work with our second pair of numerator and denominator. Again, we can simplify 24 and 12 because they are diagonal to each other. To simplify 12 and 24, we can divide 12 and 24 by their greatest common factor. And again, the greatest common factor for 12 and 24 will be the biggest number that can go into 12 and 24 evenly. Yes? The greatest common factor for 12 and 24 is 12, because the biggest number that can go into 12 and 24 evenly is 12. So we will divide our 12 here by the GCF, which is 12. Yes? 12 divided by 12 is 1. So we will shrink our 12 to a 1. I love seeing all these ones. It's easy to multiply by 1. And again, we will divide our 24 by 12. And we're dividing by 12 because 12 is the greatest common factor for 12 and 24. Don't forget. 24 divided by 12 is 2. So we will shrink our 24 to a 2. Look how the problem looks so much more attractive. Yes, attractive. What do we have left? We have 1 and 1 times 2. You've got to be kidding me. This is much easier. Man, listen. Simplify before you multiply. After simplifying, we will multiply the new numerators. Yes? We'll do 1 times 2, which is 2. And then we will multiply the new denominators, which is 1 times 5, which is 5. So our final answer here is 2/5. Can you believe that? All these big numbers give us just 2/5. I know some of you are still not convinced that we should simplify before we multiply. Let me show you why, again, you should always simplify before you multiply. Let's work the problem without simplifying and see what will be the end result. What do we have? 5 over 12 times 24 over 25. Yes? Again, when we multiply fractions, we can multiply the numerators. 5 times 24 will give us 120. And then 12 times 25 will give us 300. You multiply the numerators, you multiply the denominators. But look at that monster! Woo! Woo! What are you? Man, you better get off my board. Look how big that thing is! Why would you want to work with 120 over 300? Look how big that thing is. You want to work with that? No, neither do I. So, you should always simplify before you multiply. Simplifying gives us really small numbers. Of course, if we were to write 120 over 300 in the simplest form, we divide both of them by what? 60? We will still get what? 2 over 5. But come on, let's get real. Who wants to work with that monster right there? That's a monster. Get off the board. Get off the board. We don't want you on the board. Simplify before you multiply. Yes. How are you guys feeling? How are you guys feeling right now? All right, I'm gonna do one more with you, and then I'm gonna give you guys a chance to shine. Okay? All right, let's do 4 over 11 times 22 over 27. Never forget, my friends, always simplify before you multiply. Yes? Again, we would like to multiply 4 11ths by 22 27ths. Whoa, that sounds big. Sounds like a lot. So, our first step will be to simplify the fractions. To simplify the fractions, we can divide a numerator and a denominator that are diagonal to each other by their greatest common factor. Let's start with this 11 and this 22. We choose a numerator, we choose a denominator that are diagonal to each other. To simplify 11 and 22, we can divide 11 and 22 by their greatest common factor. Again, the greatest common factor for 11 and 22 would be the biggest number that can go into 11 and 22 evenly. The greatest common factor for 11 and 22 is 11. Yes, 11 is the biggest number that can go into 11 and 22 evenly. So we will divide 11 by 11, and 11 divided by 11 will give us 1. So we will shrink our 11 to a 1. Then we will divide 22 by 11 as well. We have to divide the numerator and the denominator by the greatest common factor. 22 divided by 11 is 2. So we will shrink 22 down to a 2. Yes? So far so good, my friends? All right. Now, let us go to the second pair of numerator and denominator. We want to simplify 4 and 27. We can simplify them because they are diagonal to each other. To simplify 4 and 27, we will have to find the greatest common factor for 4 and 27, or the biggest number that can go into 4 and 27 evenly. Yes? Now, the greatest common factor for 4 and 27 is 1. Because the biggest number that can go into 4 and 27 evenly is 1. And whenever the greatest common factor is 1, yes, we will not divide the numerator and the denominator by 1. Because dividing by 1 wouldn't make a change. Because 4 divided by 1 is still 4. Yes? And 27 divided by 1 is 27. So dividing by 1 wouldn't change anything. So whenever the greatest common factor for the numerator and the denominator is 1, we will leave the numerator and the denominator alone. No dividing by 1. So let's write back what we have after simplifying this pair. The 4 stays, but 11 shrunk to a 1. We shrunk 22 down to a 2. And 27 stays. Yes? After simplifying, we will first multiply the new numerators. So 4 times 2 will give us 8. And then we will multiply the new denominators. 1 times 27 will give us 27. So our final answer is 8 over 27. This is fun stuff! Come on! This is exciting stuff! Do I need to prove to you again why we should be simplifying before multiplying? I love proving it to you because somebody is there saying still, I am not simplifying before I multiply, Sion. I'm not doing it. Jada, is it you? Riley, is it you? Marcus, is it you? If you choose not to simplify, look what will happen. You'll multiply the numerators first. 4 times 22. That will give you what? 88? Yes? And then you'll do 11 times 27. And that will give you 297. Look at that monster! Whoa, that is scary, man. That is scary stuff. Who wants to work with 88 over 297? Look how big those numbers are. Simplify. It's easier to simplify and multiply numbers like 1 and 4 and 2. Easier. Again, if you simplify, you will, we can write this answer here, or this fraction, in its simplest form. We will get the same answer if we divide both by 11, yes? We'll still get 8 over 27. But why choose to work with those big numbers? Why would you want to do that? Don't do it, okay? All right. So again, our final answer is 8 over 27. All right. Guess what time it is? Oh, yes. It is your turn to shine. Come on. Your turn to shine. Hey, your turn to shine. Come on. Come on. Let's try 2 over 45. 2 45ths times 9/28. So what I want you to do for me here is pause the video and give this problem a try. Remember the plan. I'm watching you. I can see you. Simplify before you multiply. Parents, make sure. Grandparents, uncles, aunties, older siblings, make sure these scholars simplify the fractions before they multiply the fractions. Yes? Thank you for supporting me. I believe in you, my friends. Pause the video, give it a try if you need to. You can go back and watch the previous examples, but I want you to try this on your own and then come back and let's see if we get the same answer. Yes? All right. Welcome back. Welcome back. How are you feeling? How are you feeling? Come on. Give me a pump. Give me a pound. Give me a pound. Give me a high five. Come on. Come on. Come on. Ooh, this is fun stuff. This is exciting stuff. So, before we multiply, we are going to simplify. And to simplify, we can divide a numerator and a denominator that are diagonal to each other by their greatest common factor. Yes? So you can choose whichever pair you want to work with first. Let's work with 2 and 20 first. We have a numerator, we have a denominator, and they are diagonal to each other. That's very important. The pair you choose to simplify must be diagonal to each other, not across from each other. Not across, yes, or not above or below, but diagonal to each other. Yes? All right. To simplify 2 and 20, the rule says we can divide them by their greatest common factor. The greatest common factor of 2 and 20 will be the biggest number that can go into 2 and 20 evenly. Yes? Now, the biggest number that can go into 2 and 20 evenly is 2. So the greatest common factor for 2 and 20 is 2. So we will divide 2 by 2. And 2 divided by 2 is 1. So we will shrink this 2 to a 1. And then we will divide this 20 here by 2. And 20 divided by 2 is 10. So we'll shrink our 20 to a 10. So far, so good? Perfect! Now, let's work with the second pair of numerator and the denominator. We want to simplify 9 and 45. To simplify 9 and 45, we can divide 9 and 45 by their greatest common factor. And again, the greatest common factor for 9 and 45 will be the biggest number that can go into 9 and 45 evenly. Yes? The biggest number that can go into 9 and 45 evenly is 9. Therefore, 9 is the greatest common factor for 9 and 45. So we will divide 9 by 9. And 9 divided by 9 is 1. So we will shrink this 9 to a 1. And then we will divide the 45 by 9. And 45 divided by 9 is 5. So we'll shrink 45 to a 5. Again, notice I divided the numerator by 9 and the denominator, that's diagonal, by 9 as well. And the denominator, that's diagonal, by 9 as well. Yes? I divided the numerator by 9 and the denominator, that's diagonal from this 9 or to this 9 by 9 as well. I divided both by 9. You must divide both the numerator and the denominator by the GCF. Yes? So, we are done simplifying. I hope you simplified correctly. Did you simplify correctly? Good job. Now, let's put back what's left after simplifying. We have 1 and a 5 and 1 and a 10. This is kindergarten stuff to multiply. Easy stuff. So after simplifying, we will multiply the new numerators. So we will do 1 times 1, which is 1. Yes? And then we will multiply the new denominators. 5 times 10 is 50. Yes? So we multiply the new numerators, 1 times 1, and then we multiply the new denominators, 5 times 10. So our final answer is 1 over 50. Did you get 150 yet? Oh, 1 over 50. Come on! Come on! For those of you who are still there saying, I have to prove to you, to those who are saying, well, did simplifying really made a difference? Somebody is there asking that question. So let's see what would have happened if we didn't simplify. If we didn't simplify, we would go right ahead and multiply the numerators first. 2 times 9 will give us 18. Yes? And then we will multiply the denominators. 45 times 20, that's 900. What in the world is that? Who wants to... Man, you guys better simplify before you multiply. And avoid those monsters. Avoid those dinosaurs. Yes? You don't want to work with those big numbers. Simplify before you multiply. Of course, if we were to write 18 over 900 in its simplest form, we will divide the numerator and the denominator by 18, and we will still get 1 over 50. But why choose to work with a monster when you can work with babies? Say it with me, my friends. Simplify before you multiply. All right. We're going to do one more, and then we are out of here. One more for the road. All right. Let's do 2 over 3, or 2/3, times 6/7. I'm being very nice, yeah? I'm sending you guys off with some baby stuff. But don't you dare skip the simplifying step and go straight to multiplying. No, I just want you to feel good about yourself. So you're going to simplify, then multiply. Pause the video, give it a try, and then come back and let's see if we get the same answer. Yes? I believe in you. I believe in you. I believe in you. I believe in all of you. You guys got this. Give it a try. All right. Welcome back. Welcome back. How are you feeling? I can see the confidence glowing off your faces. And I love it. I love it. That means that you have mastered the concept. I love the confidence. The confidence is important. But we must go step by step. So first we are going to simplify before we multiply. To simplify, we can choose a numerator and a denominator that are diagonal to each other. Yes? And we will divide them by their greatest common factor. The greatest common factor for 3 and 6 will be the biggest number that can go evenly into 3 and 6. Yes? The greatest common factor, or the biggest number that can go into 3 and 6 is 3. So the greatest common factor for 3 and 6 is 3. So we will divide 3 by 3. 3 divided by 3 is 1. So we will shrink this 3 down to a 1. And we will divide the numerator 6 by 3. 6 divided by 3 is 2. So we will shrink our 6 to a 2. So far, so good? Super. Now, let's go to the second pair of numerator and denominator. We would like to simplify 2 and 7. So to simplify 2 and 7, we can divide 2 and 7 by their greatest common factor. The greatest common factor for 2 and 7, or the biggest number that can go into 2 and 7 evenly, is 1. Yes? So since the greatest common factor for 2 and 7 is 1, we're not going to divide by 1. Because remember, dividing by 1 wouldn't change anything. Any number divided by 1 remains itself. Yes? If we divide 2 by 1, we will get 2. There is no change. If we divide 7 by 1, we will get 7. There is no change. So whenever the greatest common factor is 1, we will not divide. Yes? So let's write back what is left after simplifying the first pair. The 2 stays at the top here, but we shrunk the 3 to a 1. The 6 we shrunk to a 2, and the 7 stays. Yes? After simplifying, we will multiply the new numerators. 2 times 2 will give us 4. Then we will multiply the new denominators. 1 times 7 will give us 7. So our final answer is 4/7, or 4/7. How did you do? Very good! Very good! I'm so proud of each and every one of you. For getting the answer correct, I want you guys to give yourself the biggest pat on your shoulder. Come on, come on, pat it up, pat it up, pat it up, pat it up. Now again, I have to prove it because I know somebody's there still saying, Sion, I will not simplify before I multiply. Some of you are still not convinced, yes? If you were to work this problem without simplifying, let's see what would happen. You have 2/3 times 6/7. If you skip the simplifying step, you go straight ahead and multiply the numerators. 2 times 6 will give us what? 12. Yes? And then you multiply the denominators. 3 times 7 will give us 21. But why you want to multiply these big numbers when you can multiply 2 and 1? Yes? Simplify first. Of course, if we were to write 12/21 in a simplet form, we will divide both by 3. And we will still get 4/7. But why go through all of that when you can simplify and work with baby numbers? Yes? Say it with me. Simplify before you multiply. Say it, let me hear. All right. Very good. I had a good time. How about you? All right. I really hope you guys enjoyed my video. I really hope you guys found it helpful and useful. Yes? Until next time, enjoy your math homework and your math practice. Thank you.